Got another set of questions for A-level chemistry multiple choice practice. So this is organic number 8. If you wanted to check out the other videos in the playlist, I'll put the link to that at the top of the screen now. Hope you liked the video, hope you found it helpful, and if you haven't already subscribed to the channel, I would love you to do so. But as always, the link to the questions in the description of the video if you want to try them first. So starting with number 1, nice easy one this one. What is the electrostatic attraction in a covalent bond between? It's a shared pair of electrons and the nuclei of the bonded atoms. So answer A. Number 2 is basically asking why alkenes are more reactive than alkanes, and it's down to the fact that the pi bond is weaker than the sigma bond. So option C is that one. The bond enthalpy of the CC sigma bonds is higher than that of the pi bonds. Number 3, you'll notice I've drawn up the generic equation for the hydrolysis of an iodoalkane. So we're going to get an alcohol and an H+ ion and an I- ion. So we've got silver nitrate in there as well. So those silver ions are going to react with those iodide ions and they're going to make silver iodide, which is a yellow precipitate. So the answer was D. Number 4, around carbon X, we've got 3 bonding regions. Remember, double bond counts as one region. Around carbon Y, we've got 4 bonding regions. So this is going to be trigonal planar, and this one's going to be tetrahedral. So option B. Number 5, so the functional groups in geranyl are, we've obviously got alkene functional groups and we've got a primary alcohol. So we're going to need bromine water to pick out the alkene, so that leaves B and C in play. And then for that primary alcohol, we need acidified dichromate 6. So option C was the answer for that one. Number 6, so the first thing I'm going to do is work out the moles of alcohol that's been burnt. So that's just mass over the MR. So 0.05 moles of alcohol. So therefore we're going to need 7 times as many moles of oxygen for complete combustion. So that's 0.35 moles of oxygen, and then we just multiply by 24 dm cubed to get the volume at RTP. So that's 8.4 decimeters cubed, so option D. Number 7, which statement gives a valid scientific reason for global warming? Well, it's option A. The infrared radiation causes the bonds in the CH4 molecules to vibrate more. Number 8, the thing to remember is it's the chlorine radical from a CFC that breaks down ozone, so that's option C. There's that chlorine radical there. Moving on to number 9, so the first thing I'm going to do is spot the amide group. So it's a nitrogen that's directly bonded to a C double bond O. So we've got that going on in A, in C and in D. And then to make it a secondary amide, we need to have 2 carbons bonded directly to the nitrogen. And obviously that only leaves room for 1 hydrogen. So it's option C. Moving on to number 10, first thing I'm going to do is work out the moles of each of the reagents, because we've got the mass and the MR of the amine and we've got the concentration and the volume of the HCl. So mass over MR for the amine gives 0.03 moles and concentration times volume for the HCl gives 0.04 moles. So obviously that makes the amine the limiting reagent, which is going to mean we're going to get the same number of moles of the ethyl ammonium chloride. So turning that into a concentration, it's moles divided by the volume. The volume is going to be that 20 cm cubed, 1.5 moles per decimeter cubed. So option C. Moving on to number 11, so we've got to pick out the key absorptions on the infrared spectrum. So we've got the OH of an acid and C double bond O. So we've definitely got a carboxylic acid here. So that means B and D are in play. But then there's this absorption here, which we can't ignore. That's the OH of an alcohol. So that means that it's option D. Number 12, just need to remember that when acyl chlorides react, the chlorine and the hydrogen, in this case from the amine, are going to combine to form hydrogen chloride. So it's option A. Moving on to 13, so which statements are true? The peak for component X shows the mass of 1 mole. No, it doesn't. It shows the retention time of X, so that one's not right. Component Y stays in the column for longer than component X. Yep, that's right, because it's got a longer retention time. And then statement 3, component Z consists of more than half of the sample. Well, what we're going to have to do is work out the relative amount of Z in the mixture. So we're going to take its relative peak area and divide by the total peak area. So 5.5 over 10, 0.55, so it's over half, so that statement's true. So 2 and 3, option C. Number 14, so we're looking for compounds that have got only 2 carbon environments. So number 1 would produce 2 peaks because we've got 2 different carbon environments in it. Likewise for number 2, but number 3 has got 3 environments because these sort of purple carbons, they're all unique to each other but different to the others. So 1 and 2 only, so option B. And finally number 15, which statements are true about polychloroethene? Well, to be photodegradable you need C double bond O in it, well it hasn't got that. And to be biodegradable, it needs either OH or NH, so it can kind of interact with water. Hasn't got that either, so 1's not right. Number 2, when incinerated, it produces toxic waste products, which need to be removed. That's right, because any chlorine-containing polymer is going to produce HCl when combusted. And statement 3, it can be recycled and processed for use as an organic feedstock. Well, that's true of all polymers, so 3 is correct as well. So 2 and 3. Option C.